Hello everyone, I'm Nathan, and today I'm going to be talking about AC sine waves. But first, what is AC? AC stands for alternating current, meaning that the direction that the current travels in alternates. So if you assume the first direction to be positive, the current then goes from positive to negative, also known as oscillates. How's it a sine wave? First, the reason for these oscillations occurring is because the AC voltage is changing polarity as time passes. This is because AC voltage is induced in the armature, meaning that the armature of the generator is cutting through magnetic field lines, causing a current to flow. And how this current flows is when the armature moves in the direction of the field lines, then the current is zero. But when it's passing perpendicularly, the current is a maximum or minimum, and the rest of the motion during the armature cycle causes the rest of the wave. And the result is a sine wave. But now that you know what AC stands for, and that it's a sine wave, let's see how you can represent AC in sinusoidal form. But first, let's see a physical representation of a sine wave. Okay, so that wasn't a perfect sine wave, but let's see and analyze the sinusoidal equation for current and look at a normal sine wave to see it properly. This equation is used to find the value I, which is the current at a specific time, and uses I max, omega, t, and theta. Now we have I max, and this is the maximum value for current, as equal to the peak current, which is the value for I when you measure how high the current can get from the middle point of the wave. In this case, omega means angular velocity, which is how many radians the wave moves per second. This can also be written as 2 pi times frequency, or 2 pi over the period of the wave. But what matters is that it's the amount of radians the wave moves per second, which means you can calculate the current at a specific time by multiplying it by that time, which will give you the angle at that time. Now the final part of this equation is plus or minus theta. This means if the circuit isn't purely resistive, the wave will be translated 90 degrees to the left if there is a capacitor, or 90 degrees to the right for an inductor. This also shows leading and lagging behavior. If the wave is moved left compared to the voltage's waveform, then it's leading. And if it's moved to the right, it's lagging. And you can remember this with the word civil, since the C leads the V and the L lags the V. Okay, since you now know what all the components are, I'll make a sine wave and you try and figure out what the maximum current and the angular velocity are. So this is the wave. I'll be back with the answers in 10 seconds. If you need more time, just pause the video.